My talk today is, as the title says, it's about Asian river fish in the Anthropocene. Okay, now you all know that river ecosystems face multiple threats. Some of those have been covered this morning, some will be covered later on. For example, Julian's going to be giving a talk on invasive species. I'm not going to talk about those invasives at all today. I'm going to focus mainly on flow modification, a bit on overexploitation, and how they are likely to interact with global climate change. Now, what about this Anthropocene word in the title? Many Earth system scientists take the view now that the Earth system is dominated not by natural processes, but by human processes. You can see the global footprint, for example, dominating much of the Earth's surface. You can see world population growing exponentially, and you can see CO2 emissions from fossil fuels changing the climate. Now, you might argue that you could actually date the start of the Anthropocene back to about 1980. That was the time when anthropogenic releases of nitrogen became greater than natural fixation of nitrogen. Literally, the Earth's nitrogen system was dominated by human activities. And if you look at the work of Stefan and his colleagues over the last few years, they've coined this term the Great Acceleration, showing how humans are changing all aspects of the biosphere by, for example, excessive consumption of water, excessive consumption of nutrients, and so on. This graph includes a whole host of things, including, incidentally, the increase in the number of McDonald's restaurants. Now, Dave Strayer and I tried to look for these Anthropocene signals in fresh waters, and they were real easy to find. You can see the signals there with respect to water withdrawals, nitrogen loading, large dam density, alien species, and fisheries landing. So the Great Acceleration is very clear in fresh waters. And why does this matter? Most of you probably know the fundamental point here is that fresh water is an incredibly rare resource, an incredibly rare habitat. Most fresh water on Earth is frozen or underground. Only about 0.3% global fresh water is actually on the surface, available as habitat for animals. And only 2% of this consists of rivers. So rivers are a vanishingly rare and vanishingly small habitat. And yet, when you look at the number of species which live in fresh waters, just lakes and rivers, we find 41% of the fish live in fresh water. That's about 25% of the vertebrates. And then if you bolt onto that things like turtles, crocodiles, and so on, you find about a third of all the vertebrates live in this tiny area of fresh water. So given the Anthropocene signals in fresh waters, it's not too surprising that this biodiversity is endangered. The other problem is, and we heard this morning, for example, in the talk about Thai fishes, is that a great deal is still not known about fish biodiversity. And if you extend out into other groups, invertebrates, for example, especially invertebrates in the tropics, you find that our knowledge of freshwater animal diversity is very poor indeed. The estimated global total of freshwater species is 126,000. That's 9.5% of all the described species on Earth. So you have this extremely high biodiversity in a very small, very threatened type of ecosystem. So it's not too surprising then if we look at population trend data for freshwater animals that the trends in decline of freshwater animals are considerably more than the declines in animals in the marine environment or in the terrestrial environment. These are data from WWF's Living Planet Index showing a 55% decline in freshwater relative abundance over time. So the vulnerability of rivers in particular extends from a few characteristics which are really quite key. First of all, the vulnerability relates to the fact that rivers are receivers. They receive things from the drainage basin around them. But as well as being receivers, picking up the changes that occur in the terrestrial landscape, they're also transmitters because they transmit those changes downstream as well. And because of river connectivity, there is no such thing as a local impact in a river system. That's quite different from a terrestrial environment. Secondly, in order to keep rivers healthy, we have to maintain flow variation and inundation of the floodplain. That's precisely the sort of thing that humans do not like and try to regulate. The third point, and this relates to the richness of freshwater systems, is that most freshwater species or river species have small geographic ranges and limited dispersal ability. There's a very high turnover between drainage basins. That's particularly true in the tropics, which have never been glaciated. And so we see that river basins aren't substitutable in biodiversity terms. If you conserve one, you don't conserve them all. That creates a real problem for biodiversity conservation. And then the final point is really the medium is the message. Freshwater is something that we consume and contaminate. Thus, we reduce its quantity and its quality as a habitat for freshwater animals. So that means you end up seeing newspaper headlines like this, that human demands for freshwater are driving animals to extinction. Okay, this is similar to some of the data that Will showed you this morning. I said, okay, humans are driving freshwater animals to extinction. Where's the evidence? Well, we go to the gold standard, that's IUCN, and they tell us that 38% of freshwater fish in Europe are endangered, 39% in America, i.e. they're critically endangered, or vulnerable. Look at amphibians. 31% of amphibians globally are endangered, but another 25% are data deficient, mainly because they're quite rare already. Add those numbers together and things start getting quite scary. I work in Asia, and my group's worked on river turtles a bit. And it turns out that over 80% of river turtles in Asia are globally threatened by overexploitation as trade for traditional Chinese medicine. Now, the other 20% are by no means in good shape. They are actually mainly data deficient, so rare that we cannot say anything about their population changes. So the vertebrates look as though they're in pretty bad shape. The invertebrates we know much less about. Dragonflies, you could have 40% of the species threatened if you consider data deficient species to be at risk. And for freshwater crabs, it goes up to 65%. Now, Paul Skelton, in his talk this morning, mentioned Melanie Stiasny, the fish taxonomist, and she showed me this data set, which shows Anthropocene extinctions. And it shows very clearly that 90% of freshwater fish extinctions have occurred very recently. It's quite a different pattern of extinction to, say, the extinction of terrestrial birds. So what we may be on now is the cusp of an extinction of freshwater animals. And we can see evidence of that in some very big charismatic species. This is the Yangtze river dolphin, considered functionally extinct in 2007 after successive surveys of the river failed to yield any animals. Not one, none, zero, nada, none. That picture there is the last known Chinese river dolphin. Now, this isn't a fish, I know, but this is also from the Yangtze River, and this is the last Yangtze female softshell turtle. She's behind bulletproof glass in Changsha Zoo, the only one, and she's 80 years old. Now, there is a male in another zoo in China. He's 100. So this could be another species about to disappear. Now, these aren't small, trivial species. These are quite big, charismatic things. And they are threatened by a multiplicity of factors. And I want to show you just how frightening this global threat to river systems is by talking about a paper which came out last year in Nature. This was a paper led by Charlie Vorismati and including guys like Pete McIntyre, Mark Gessner, Stuart Bunn, and myself. We tried to put together a global analysis of the threats to biodiversity. Now, this is just threats, right? There's no biodiversity data in this. And we looked at 23 weighted threat factors for which we could get global data: watershed disturbance, pollutants, water resource development, and biotic threats. A number of threats in number of drivers in each of these groupings. We carried out a pixel scale analysis, and for some cases we asked computer modelers to help us to route the drivers downstream, where we knew that the threat would be carried downstream, or to divide by annual flow, where we knew that the flow of the annual river would annual flow of the river, would dilute the intensity of the threat. And then what we did was we compared threats to human water security and to biodiversity, because we know that the human use of water and the amount of water that's left over for biodiversity is linked. So it makes sense to look at the two of them together. Now, to show you this diagrammatically, here are all the different drivers that we used. Don't worry too much about what they are. I just want you to see that you can really easily switch the effect of, say, pollutants on human water security to biodiversity. They have an effect. The question is, how do you weight them? So a lot of our analysis was figuring out how best to weight these things with respect to human water security or biodiversity. Because, for example, a dam is good for human water security, but it's lousy for biodiversity. And you can think of other examples. So this is what we got. We put all our drivers together, did the analysis, and produced the global maps. I'll stop here for just a moment, because when you look at these maps, the first thing that you think is, my God, they're almost the same. But they're not, actually, when you drill into some areas. For example, look at the United States and Europe. They show up as good for human water security, but quite bad for biodiversity. But for most of the rest of the world, the threats to biodiversity and the threats to human water security are almost the same. Now, there's another way of looking at these maps. I'll show it to you now. This is where you plot high and low human water security threat against high and low threat to biodiversity. And the red in this map are the parts of the world where human water security and biodiversity threat is high. The yellow is where only biodiversity threat is high and human water security is low. And this grey is where they're both low. There is nowhere on the world where threats to human water security is high, but threats to biodiversity is low. Nowhere. Now, the Anthropocene world is basically all the red parts and probably some of the yellow parts too. And the bit that I'm going to talk about for the rest of this talk is this area here, East and South Asia. Now, this is an important part of the world because of the diversity that it holds. The freshwater ecosystems of the world analysis shows that this is a particularly rich area with respect to fish biodiversity. For some years, I've been compiling data on fish biodiversity in rivers around the world and in Southeast Asia. Now, here's a summary of that data. I'm only summarizing the top ranks. And first thing I want you to know is that if you rank the rivers around the world with respect to fish biodiversity, 12 of the top 20 rivers in the world are in Asia. And these are the top ranked ones among those 20. Now, point one, here are the species totals. The species totals vary depending upon who you ask and depending upon which data set you use. But they're pretty high. The Mekong data set ranges over about 1,000, and there are actually estimates of over 2,000 out there. Probably wrong. The rank globally in terms of species, the Mekong ranks third, although some people think it ranks second, but third I think is creditable enough. Then you've got fourth, the Ganges, fifth, the Yangtze, and so on. What's interesting about these data is if you rank the rivers by their drainage basin area. If you do that, you see that these rivers don't rank highly globally at all. So they're not big rivers. They're quite small rivers globally, but they contain a lot of species. They're disproportionately rich. So that's the biodiversity data. Now let's go back to the threat data. This is the threat data from the Voros-Marti et al. Paper blown up a bit. Here's the threat to biodiversity. I want you to look at two things here. First of all, China, all red and yellow. The coloring is intuitive. If it's red, it's bad. If it's yellow, it's pretty bad. If it's blue, it's good. Note there's no blue. This is Thailand here, also in quite bad shape. But this green area up here is the Mekong River. So you've got parts of the region which are in good shape and parts which are in very bad shape. Threats to human water security show much the same thing. And it's this intensity of threat to human water security that makes me think of Asia as being really a mirror of the Anthropocene. And this is the Geographical Society of America's monthly magazine. They asked the question, are we living in the Anthropocene? A couple of years ago. And the picture there is Shanghai in China. So they think that Asia is the first place where we are seeing this global dominance of the environment. Anthropocene rivers in China, for sure. When you look at Chinese rivers, and let's just think about the Yangtze for a minute, it receives 25 billion tons of wastewater annually. That's 40% of China's total, virtually all untreated. Fisheries landings from the Yangtze are now less than 20% what they were in the 1950s. 40% of the river sites that the Chinese Ministry of Environmental Protection surveys are heavily polluted. Fisheries have collapsed over many of the major rivers in China, and fish kills have entirely eliminated fish from a significant proportion of the river length. So quite scary stuff. Now, in my newspaper, I often see headlines like this, and I picked this one particularly because it juxtaposes the quality issue, the cancerous river, with the quantity issue, the sheer shortage of water in parts of China. And this picture I clipped out of my newspaper a few weeks ago. This is a fish kill in the Yangtze River. This whole river surface here is covered with dead fish because of lack of oxygen in the river, in the main part of the Yangtze. So, the Yangtze is already, and parts of China and Asia are already seeing these terrible Anthropocene changes. And yet nobody's begun to think about how climate change is going to ratchet this up. Climate change will have certain predictable effects on monsoons in Asia, because the monsoons drive the natural flood cycles in the region upon which the rivers depend, and all the natural flood cycles depend. We know from global climate change models that as the Earth warms, the monsoons will become more extreme. The rainfall may not change, but it'll become more intense in the wet season, and there'll be much less of it in the dry season. So we'll get more extremes. This is a problem because these Asian rivers already show quite marked flow seasonality. Here's 30 years of flow from the Yangtze. These are maximum flows, minimum flows, and mean flows. So that arrow represents the current uncertainty. Now, as the Earth warms up, that uncertainty, that amplitude will become much greater. So as well as having more extreme monsoons, we'll have warmer dry seasons, which means less water going into rivers. Fish, if they want to stay in their own thermal envelope, their own thermal preference, will have to move. They'll have to make compensatory movements. Now, how do you do this? If you're a fish, well, you have to swim upstream to where it's cooler, or you have to swim north to where it's cooler. Now, you might like to think about doing an experiment in the pub tonight where you look and see, well, what are the global predictions for climate change in the systems that I know? And then think to yourself, how far would a fish have to swim uphill to compensate for that? The adiabatic rate of temperature change is about 0.7 degrees per 100 meters. So if your temperature is going up 4 degrees centigrade, you have to go a long way up. And then you might think, well, can the fish do this? Is there enough river? Are the mountains tall enough? Are there dams that are going to prevent it moving? And what about flowing north? What if the rivers only flow east-west? So bad stuff can happen. And global climate change, which will change the monsoons and will change the flow patterns, are changing the very things that the fish depend upon and upon which they are adapted to. And then there's one other thing. Most of the main Asian rivers come from the Himalaya. And this picture says more than 1,000 words. This is the same place, 1921, 2009. Where have the glaciers gone? So this will add a great deal of medium-term uncertainty into river flows, and hence the environment for river fishes. So, obviously climate change will not happen in a vacuum. Humans will respond themselves to climate change. And they will do that by trying to avoid floods, droughts, and uncertainty, and by building more dams for flood protection, for water storage, for people and agriculture. But in addition, of course, we're going to need to build dams because we're going to have to switch away from the use of fossil fuel. Our dependence on non-fossil fuel sources is going to have to increase, and dams are often perceived, especially in Asia, to be an environmentally friendly way of generating electricity to fuel economic development. Now, dams will disrupt the lateral and longitudinal connectivity of rivers that's mediated by seasonal flows upon which fish depend, and they will also block fish migrations and fragment populations. This will be particularly bad for large species which have to travel long distances and which may already be overexploited by fishing. So, as the species which are likely to disappear most quickly in the future, large river fishes can be regarded as sentinel species. Now, here's one. I think this is my first picture of a fish so far in this presentation. This is Probarbus juliani. It's Julian's golden carp. It's an endangered species already and has been practically eliminated from Malaysia and Thailand by dams and overfishing. It now remains mostly in the Mekong, yet as that graph shows, that's data from Ian Baird, the populations in parts of the Mekong are in decline. Now, what about China? Remember I showed you the situation. China comes up red for human water security. China is going to need to build more dams to fuel economic development. It already has 45% of all the large dams. And in 2004, it overtook the US to become the biggest generator of hydropower in the world. Since 2007, it's been the biggest emitter of carbon dioxide from sulfur-rich coal. So, emitting that coal is not a viable solution in the long term, using that coal. Energy demand in China is increasing by 3% annually. A back-of-the-envelope calculation means that they'll be using half the energy in the world by 2050. The Chinese have just published their 12th five-year plan. That envisages maintaining their current rate of growth at about 7%. Now, inflation in China is already about 5%. So you're going to have to grow more by a lot in order to maintain that 7% net annual growth. They also intend to reduce carbon intensity and reduce reliance on fossil fuel. So if the economy is growing and you have to reduce the use of carbon, you're going to have to produce an awful lot more hydropower. China already has the world's largest hydropower scheme, the Three Gorges Dam. And I want to introduce you here to Mao Zedong. Now, Mao Zedong was basically the architect of the Three Gorges Dam. And the story is that he wrote this poem while he was swimming in the Yangtze in 1956. And the poem starts off by saying, "Great plans are afoot." And he says that walls of stone will stand upstream to the west to hold back Wushan's clouds and rain. Wushan's the main mountains around the Three Gorges. Until a smooth lake rises in the narrow gorges. And the mountain goddess, if she's still there, will marvel at a world so changed. An Anthropecene world envisaged by Mao Zedong. And here it is. 185 meters tall, 18 gigawatts installed capacity. That's a big, scary dam. It's the biggest in the world. Now, obviously, it has an effect on fishes in the Yangtze River. These are large fish. These are migratory fish. The Yangtze sturgeon, critically endangered. The Chinese sturgeon, critically endangered. The Chinese paddlefish, critically endangered, question mark. I'll come back to that in a moment. Only the Chinese sturgeon occurs in any other rivers in the world. They're all migratory fish. And their migrations have essentially been blocked by the Three Gorges Dam in the middle of the river. So the Yangtze sturgeon is theoretically, I can't point on there, can I? Sorry. Theoretically only up here. The Chinese sturgeon is now down here. And the paddlefish, well, we're not quite sure. I want to make the point, though, that the Three Gorges Dam was not the thing that blocked their migration, because this dam, a smaller mainstream dam, was already in place since the 1980s. The only known spawning site of the Chinese sturgeon is just here, a very small area immediately below the dam. So China's going to have to generate some more hydropower. I'm sorry to bore you with figures, but these figures are really striking. How much more hydropower? Well, if one looks at the Chinese 5-year plan and beyond, by 2020, they expect 9% of energy use to be contributed by hydropower. That's not very much, by the way, only 9%. Their present capacity is 200 gigawatts installed. That means they need 230 more by 2020. And in the next 5 years, they're planning to produce 163 gigawatts. Now, 163 gigawatts, what does that mean to you? Well, the Three Gorges Dam is 18 gigawatts installed capacity, biggest dam in the world. So that means to reach the 2015 target, they're going to have to build 9 of them. It's about 2 a year. To make the 2020 target, you need 13. And by 2020, China will more than triple the 2004 generating capacity. And that's important because that was when they overtook the United States. So you just get an idea of what is being planned here. It's quite frightening. I made up this graph here, or drew it up, I didn't make it up. Installed generating capacity of dams larger than 1,000 gigawatt hours. And you can see that in 1980 there were basically none. By 2017 they're going to be a huge number. So we're going to have many, many more dams and many more reservoirs, which tells you how much the habitat of the rivers will be altered. And these are only the ones that we know about now, not the ones that have not yet been planned and will be built before 2020. So, where are these dams going to go? Let's look again at the Yangtze. There's the Three Gorges Dam here. So we're looking at this area above the Yangtze, behind the Three Gorges Dam reservoir. And in that area, after the Three Gorges Dam was planned, a fish reserve was set up to offset the effect of the dam, and that's that grey shaded area. As of a few months ago, those red marks show the plans of the dams that are going to be built in the upper Yangtze to start getting this hydropower done. There's a lot of them. First thing I would say is if you were to draw this as a series of steps, what you find is that the tail waters of the first dam go back to the foot of the second dam, and the second dam goes up, then you go back to the foot of the third dam, and so on. So the whole river is reduced to a series of steps. And you can notice here that 1, 2 dams are going to be built inside this fisheries reserve. The solution to that is easy. The Chinese Ministry of Environmental Protection have just shifted the reserve boundaries a bit. But here's the thing. This red spot here is the only known spawning site of the Chinese paddlefish. Only known in the world. And I said that this was critically endangered, but I put a question mark beside that because the last time one of these animals was seen alive was in 2003. And studies by the Institute of Hydrobiology at Wuhan in China, hydroacoustic surveys running over 3 years, including the breeding site and the fish reserve, detected none. None at all. Now, there still are some quite cool fish in that reserve. This is Mixocyprinus asiaticus. It's the only catastomid that occurs in Asia. All the rest are in the US. It's a Yangtze endemic, occurs in that reserve, is nationally protected, but you wouldn't have much confidence over its future, given the engineering that's planned for the area. And that's not all. By no means. If we look at other parts of China, we see that China is planning long-distance water transfers of water from the Yangtze to the north of the country, which is much drier. This eastern route is almost finished. This western route is way underway. This one is proving engineeringly a little bit difficult. So the Yangtze is not just going to be changed by dams, but also by absolute removal of water. And yet, this year, China had its worst drought, and the Yangtze Valley had its worst drought in 50 years. So there had to be emergency releases of water from the Three Gorges Dam. And I'm not a lake expert, but I think that value, 20 billion cubic meters per day, is about equivalent to the capacity of Lake Windermere every day being released downstream. So there's an environmental flow project for you. Now, China is not just building on the upper Yangtze and the upper Jinsha River. In fact, it's also planning to build 13 dams on the Nujiang River, which is the upper part of the Salween River, which flows south into Southeast Asia. And this is part of the 5-year plan for the next 5 years. Now, there's the Yangtze. Now, this is the Lansangjiang or Mekong River. And this is where I want to bring you on to the other river I said I would mention. Now, China has not been slow to realize the potential of the Lansangjiang. It's already dammed a considerable part of the river. And these dams have potential implication downstream for Cambodia, Laos, Vietnam, and Thailand, who have not yet built any mainstream dams. But they did have plans to do so. Right through the 90s, there was a big scheme to put 12 dams along the mainstream of the Yangtze. And in fact, this picture comes from a paper I wrote in 2002 saying, "Don't do it, please don't do it." And fantastically, in 2002, this dam array was cancelled. Nothing to do with my paper, instead to do with the Mekong River Commission, which is an intergovernmental organization which involves 4 of the riparian states, Vietnam, Laos, Thailand, Cambodia. China refuses to join, incidentally. And in 2002, they basically decided that their mandate for managing the shared basin would be sustainable development, not just hydropower, but integrated sustainable development. And they said, right, no more mainstream dams. Now that's excellent news because the river is already the home to some fantastic charismatic species. This is the Mekong giant catfish. Will showed its tail in his seminar. This is a picture from the 30s, and this is said to be a small one. It's said then that they reached 5 meters long. Here's some other cool fish. There's the Mekong giant carp, largest carp species in the world. And here's the Mekong giant stingray. Now, there's a rather sterile argument going around in fish circles as to which one of these fish is actually the biggest fish in the world. But nonetheless, what I want you to notice is they're all endangered or critically endangered. There's also a fish called the dog-eating catfish, which reaches 2.5 meters long, which is critically endangered. I couldn't find a picture of that to show you, but that's my personal favorite. Now, these fish are large representatives of a suite of species in the Mekong: white fishes, which make longitudinal breeding migrations, and black fishes, which make latitudinal breeding migrations tied into the flood season. To keep these fish healthy, you need to maintain connectivity in the system. So mainstream dams in the lower Mekong would be a really bad idea. But it would be a really bad idea also for people, because the lower Mekong Basin is the world's largest freshwater fishery. About 2.5 million tons a year. That's a quarter of the world's freshwater fishery. Its value varies a bit depending upon whether you think of its value as first catch or its value as processed catch, particularly fish sauce. But we're talking billions of dollars. And it's a vital human food supply. 20% of protein by people in Laos is fish, about 80% in Cambodia. And 40 to 70% of the lower Mekong catch is derived from migratory species. More than 50 of them, so it's a rich multi-species fishery. Now, China has already dammed the Lansangjiang, the upper Mekong. But the main fisheries yield of the river are downstream in these 3 migration zones. This is the smallest, and these 2 are more or less equivalent in size, yielding about 1 million tons of fish a year. Unfortunately, political pressures in the region have meant that there is now talk of mainstream dams on the river to generate hydropower. In the case of Laos, for example, to generate hydropower to sell to other countries. And this is what the current situation is. We have, leaving aside the 8 Chinese dams, we have another 11 of them planned further downstream. The one that is under current consideration is the Xayaburi Dam in Laos, and that's this one here, 3rd in the array. It doesn't actually matter all that much which one is being considered first, because we can predict that the first dam will be the one which is going to have the big impact. It's worth looking at what's actually going on. How is this project being considered? It's a 49-meter tall dam. It's got to have 100 kilometer meter 100 kilometers, a long reservoir. It's going to have a lot of impacts. It's going to obstruct up and downstream migrations and larval drift of fish. It's going to cause extinction of the Mekong giant catfish because the breeding site is above the dam and the fish generally spend their time below it. Downstream passage through the dams is likely to be terminal for most large Mekong fish. For example, a projection made by the MRC suggested that Probarbus juliani, which I showed you earlier on, would not be able to go through the turbines of the dam, unsurprisingly. Now, it would reduce the Laotian floodplain fishery by about 70%. But that's the smallest of the 3 migration zones in the river. So the overall effect wouldn't be very large, but it would be major for the Laotians. Okay, so the MRC has a procedure for notification and prior consultation of transboundary projects. And this process has to be completed before any country in the basin can build a dam. So the Laotians can't do it without getting the approval of all the other MRC members, in other words. But the MRC also went out and commissioned an independent EIA of this dam to see what the effects would likely be. And the EIA recommended a 10-year deferral on all dam construction in the region. Now, the prior notification agreement for the Xayaburi Dam was released earlier this year by Laos. It was consulted among the riparian states. And then in April, they decided that they could not agree. So the proposal was pushed up to the ministerial level of the 4 countries for consultation. But the Lao people want the dam construction to be built in 6 months, to begin in 6 months. So that's where we are now, a big question mark. Just to pull everything back together, let's look at how the whole thing might look. Leaving aside the dams that may be built downstream, these are all the dams that we know will be built, plus the water construction scheme. And what you can see is the whole of this part of Asia is being re-engineered. What effect this will have on river fishes in a changing world, I have absolutely no idea, but it's hardly likely to be good. So, what's likely to happen? I have 2 final things to say to you. What's likely to happen and maybe what we should do? We know humans are going to use more water in a warmer world. We know dams will fragment populations and limit the ability of fish to adapt. Fish will have to move somewhere to compensate for the warmer temperatures. Should we intervene with this? Can we implement environmental water allocations to mitigate these effects? Can we build appropriate fish passages or dams? But human populations are growing, so the intensity of impact is going to get greater and greater. So the message is very bad. But if we are actually going to try and come away with this with something positive, we have to think a little bit outside the box. So what are the final messages? What do we need to do? The first thing that we really need to do is to increase our effectiveness as scientist advocates. We need to increase and raise public awareness, irrespective of what Will was saying this morning about the difficulty of doing this, of threats to river fishes, the ecosystems services provided by river fisheries, which are obvious at least in the lower Mekong, and the importance of river biodiversity to human livelihoods. Again, obvious in the lower Mekong, not obvious at all now in China. We need to ensure that EIAs build in the needs of biodiversity, water resource decisions, build that in. We need to improve protected area designs to ensure that dams don't break up river connectedness. We need to learn more about data-deficient species and develop conservation plans for species which are critically endangered or endangered. But the learning more is not the most important thing. Along with advocacy, the single most important thing is to apply our incomplete existing knowledge now to actually begin to change things. Now, this is not an original thought, but we cannot wait until all the information is in. We must act now. And my final slide brings back Mao Zedong, the architect of the Three Gorges Dam, who said the most important thing is not getting the information to understand the problem. The most important thing is applying that information to change the situation. I've gone along a little bit over time. I apologize for that, but thank you for being so patient.